Hi, everybody. This brings us to what I think of as the pre-calc part of section 4.7. You've seen the trigonometry part. All right, so in this part of 4.7, we're going to simplify expressions involving inverse trigonometric functions. So they're saying to use a sketch to find the exact value of each expression, starting with the sine of the inverse tangent of 7/24. So I'm going to do all of this on the tablet. So let's switch over to the tablet. I have three examples that are, well, two other examples that are very similar to this one. So I would encourage you when we get to letter B, and especially when we get to letter C, to pause the video and try to do those ones yourself. All right, so here we have the sine of the inverse tangent of 7/24, and they're saying to find the exact value. Exact value roughly means don't use a decimal point to write your answer. All right, so what is an inverse trig function? An angle, right? If you watch the first part of the video for this, we played the inverse trig function game. So here we have an inverse trig function, which is an angle. So I'm going to give it an angle sounding name like theta. I'm going to say let theta be the inverse tangent of 7/24, because you know that the inverse tangent of 7/24 is a certain angle whose tangent is 7/24. All right. So if theta is the inverse tangent of 7/24, that means that the tangent of theta is 7/24. Okay. So now what I'm going to do is draw a right triangle starring angle theta, and I'm not going to worry about if the sides are, in the proportions they should be in. All right, so we're going to say this is angle theta right here. So the other thing you need to remember in order to do this is some old hippies came around here tripping on acid, right? So the reason I bring that up is because the tangent of theta, SOHCAHTOA, in my triangle, let's make the opposite side 7 and the adjacent side 24. So I actually did a pretty decent job of making my triangle in proportion, but that was just luck. All right, so let's talk for a minute about what are we trying to find. We're trying to find the sine of the inverse tangent of 7/24, but of course now we are calling inverse tangent of 7/24 theta. So we're trying to find the sine of theta. And of course the sine is the opposite over the hypotenuse. So what we need to do is find the hypotenuse for this triangle. So why don't we put an H here, H for hypotenuse, and we'll use our Pythagorean theorem, which is going to tell us that H squared is 24 squared plus 7 squared. 24 squared is 576. 7 squared is 49. It just so happens that 576 plus 49 is exactly 625. And so if H squared is 625, that means H is the square root of 625, which is 25. So now we have what we need. So now I'm going to say, therefore, actually, why don't we do this in a different color so it stands out? Therefore, the sine of theta, which is what we're trying to find, is the opposite over the hypotenuse The opposite is 7, and the hypotenuse is 25. So believe it or not, the exact value of the sine of the inverse tangent of 7/24 is 7/25. That's how you do that. All right, so let's switch back over to the slide and look at letter B. So letter B is asking for the cotangent of the inverse sine of 5/13. So at this point, if you're feeling frisky and you want to try that one, please, please, please feel free to pause the video and try that one. It should be very, very similar. I will, of course, be here waiting when you're finished. Okay. I'm going to switch over to the tablet. Not with that button. Okay, here we go. So we're looking for the cotangent of the inverse sine of 5/13. So what is an inverse trig function? An angle. So let's give this an angle sounding name. You could call it theta again. We're sort of done with the theta from the last problem, but I think I'll call it alpha this time. So let's let alpha be the inverse sine of 5/13, which means that the sine of alpha is 5/13. All right, and of course, some old hippies came around here tripping on acid, so katoa. This is opposite, this is hypotenuse, so I am going to draw my right triangle. And maybe it looks something like that. Call this alpha. All right, so the opposite side is 5, the hypotenuse is 13. All right, so what are we trying to find? We're trying to find the cotangent of the inverse sine of 5/13, which is the cotangent of alpha. Now, some old hippies came around here tripping on acid does not help with the reciprocal functions, right? It doesn't help with cosecant, secant, or cotangent. So for those, you have to know your reciprocal identities. So hopefully you know by now that the cotangent is the reciprocal of the tangent. So TOA, tangent is opposite over adjacent. That means cotangent is adjacent over opposite. So we need the adjacent side for this one. So I'll call that A. Using my Pythagorean theorem, we have A squared plus 5 squared equals 13 squared, which means A squared plus 25 equals 169. Subtract 25 from both sides, you get A squared is 144, which means A is the square root of 144, which is 12. Okay, so I think I'll write the end of my problem over here this time. I just learned maybe about a week ago that when I'm on Zoom, students cannot see about the bottom maybe half an inch of my tablet. I have to remember that. I would like to find a way to mark it actually, so I just remember never, ever, ever right there. Okay, but I think you can see this over here. All right, so we were looking for the cotangent of alpha. The cotangent is the adjacent over the opposite. We just found out that the adjacent is 12, and we already knew that the opposite was 5. So the exact value of cotangent of inverse sine of 5/13 is 12/5. All right, so hopefully that's feeling more and more comfortable each time. All right, now the last problem that's kind of like this is a little weird. So it's asking for the secant of the inverse sine of -1/2. So that negative, you want to be careful with that. So there are two ways you can do this problem, and I was kind of debating which way I want to do it. And I think I'm going to go with the one that is pretty much guaranteed to always work. But I'll tell you a little bit about the other way you could do it. So the inverse sine of -1/2 is actually something that you can evaluate, unlike inverse tangent of 7/24 or inverse sine of 5/13. Okay. Inverse sine of -1/2, -1/2 is one of those special values, right, that I can just pluck off the unit circle. So if you want to do this just by saying, well, the inverse sine of -1/2 is, what would that be, -pi/6? And then you just have to find the secant of -pi/6. So that's no problem. But I want to show you how to do it just in case, and I honestly don't know if there's a problem in the homework like this, just in case they ask you, what's the secant of the inverse sine of -2/3, right? You wouldn't be able to do it that way. All right, so back to the tablet. Okay, so I'm going to draw this picture a little different when I get to that part. First of all, what is an inverse trig function? It's an angle, and I will call this one beta. Let's switch back to black pen. Okay, so if beta is the inverse sine of -1/2, then that means the sine of beta is -1/2. Okay. So that negative, you can still use SOHCAHTOA. I mostly think of SOHCAHTOA as, you know, the opposite, the adjacent and the hypotenuse are all positive. But you can sort of tweak that a little bit. So what I'm going to do is I'm going to think of this -1/2 as -1/2. And I'll make this my opposite and make this my hypotenuse. You always want the hypotenuse at least to be positive, okay? And you can control that, okay? So if your value happens to be negative, just attach the negative sign to either the opposite or the adjacent, whatever part is in there, okay? So now I'm going to draw my triangle like this. I'm actually going to place it in the in my coordinate system like this. And so I'm going to think of -1 as being -1 on the y-axis. And then I can make my hypotenuse 2, just like that. So that'll be 2. All right. And so our adjacent will be positive. Okay, we are in quadrant 4. Okay. All right, so let's see. We're looking for the secant of beta. So cosine is adjacent over hypotenuse, which means secant is going to be hypotenuse over adjacent. So once again, we need the adjacent, which I'll put right there. Okay, so this time it's going to go a squared plus the square of -1 equals 2 squared. A squared plus 1 equals 4. Means a squared is 3, which means a is the square root of 3. Okay. Now I actually left the next slide blank, so I think I will go over to the next slide, just so I don't write on a part that I'm not supposed to write on. But I think I'm ready to write the answer. Let's see. So therefore, the secant of beta, and we know that secant is hypotenuse over adjacent. We already knew the hypotenuse was 2. We just found out the adjacent is 3. I mean, square root of 3. So if you're using MyLab or some other online homework program, they might insist that you rationalize your denominators. I think they've been doing that so far. Your calculus instructor may or may not care whether you rationalize denominators. Just to be safe, we'll go ahead and do it. All right, so it looks like 2 root 3 over 3 is the exact value of the secant of the inverse sine of -1/2. Just to check that with the way that we were talking about doing it at the beginning, why not? So we'll call this a check. One way to check your answer to a problem is to do the problem a different way and see if you get the same answer. So the secant of the inverse sine of -1/2. At the beginning of this part, I was reminding you that the inverse sine of -1/2 is -pi/6. This will be a good excuse to brush up on our evaluating trig function stuff. So of course, secant is an even function, which means that the secant of -pi/6 is the same thing as the secant of pi/6. And the secant is the reciprocal of cosine. And the cosine of pi/6 is something that, at least by the end of this semester, you should kind of know in your sleep. That is root 3 over 2. Yes, so that works. The reciprocal of root 3 over 2 is 2 over root 3, aka 2 root 3 over 3. Woohoo! All right, so there's only one more problem that I want to show you, and this is a very important one actually for calculus. It comes up mostly, I think, in second semester calculus, and that is a problem like this. So they want us to use a right triangle to write this expression as an algebraic expression in X. An algebraic expression in X is an expression that basically that only uses plus, minus, times, divide, square roots. And I think that's about it. Okay, you would not use trig functions, inverse trig functions, e to the x, ln of x, none of those special functions. You know, think just the functions that are on like a dollar store calculator. Okay. All right, so we're going to do this the same way that we were doing these other problems by drawing a right triangle. Okay, well, I've almost run out of angle names, so I think I'll go back to theta. Let's let theta equal the inverse tangent of x, which means that the tangent of theta is x. So what I'm going to do now is use some old hippies came around here tripping on acid. And for that to work, I need the tangent value to be a ratio. So I'm going to write this x as x over 1. In other words, I want to know what's the opposite and what's the adjacent. So then my right triangle will look something like this. The opposite is x, the adjacent is 1. We are trying to figure out what is the sine of theta. The sine, of course, is the opposite over the hypotenuse. So we need to write the hypotenuse in terms of x. So I'm going to put an h here. By the Pythagorean theorem, h squared is x squared plus 1 squared, which means h squared is x squared plus 1. And that must mean that h is the square root of x squared plus 1. Okay. So our algebraic expression in x, I think I can squeeze this in before I get to the part that you can't see. Sine theta is going to be the opposite over the hypotenuse. We already knew that the opposite was x, and we just found out that the adjacent is, the hypotenuse is the square root of x squared plus 1. Now, I think that is a perfectly fine answer. There is really absolutely no reason to rationalize the denominator of that. I have seen somebody do it. I don't know if your MyLab homework makes you do that. I know in one of the test writing programs that I use, not for an online class, I think they do it that way. So you know what I'm going to do? I'm going to circle this answer because I think that answer is just fine. There's absolutely no reason to rationalize the denominator of this, but just in case, all right, it would just be multiply the top and the bottom by square root of x squared plus 1, and you get this answer, x times the square root of x squared plus 1 over plain old x squared plus 1. So that's also a fine answer, but really, I don't think there's anything wrong with this. All right, and that's all I wanted to show you for the pre-calc part of this section. So we'll see you next time.